This is a polar graph. Right here, what you would think of as the origin, labeled with an O, is called the pole. Notice that you have a ray where it has an endpoint and it goes in one direction. That means it's a ray. This is called the polar axis. Uh-oh. This is called the polar axis. And the way we write coordinates in a polar coordinate, we put the radius first and then the angle. So notice, this is the point with radius 3 with angle pi over 4. This is the angle pi over 4. So understanding that one, let's do another one. Let's do 2 pi over 4. Go ahead and graph that one on your paper. Where is that? Graph another one. What is 2 pi over 3? Where is that? For you, what would be 1 negative pi over 2? All right, so going over these, pi over 4 is right here. Oh, didn't draw that straight. Right there. And I want to be on 2. So right there is this point. I'll label it A. The next one, I'll label this point B. 2 pi over 3 is right here. 2 pi over 3. And the radius is 3. And my apologies, I wrote that point wrong. The parentheses should be outside. There we go. Okay, last one. I'll label this point C. I got to go negative pi over 2, so I'm going to go clockwise this way. So this is negative pi over 2, and your radius is 1, so right there. So this one was C, this one is B, this one is A. Okay, now that you have these, I'm going to do this in green. Give me negative 2 pi over 4. Where do you think that would be? Negative 2 pi over 3. Where do you think that would be? Negative 1, negative pi over 3. Where do you think that would be? I'll call these primes. I'll give you guys a moment to think about it. Okay, so let's go over these. I'll do the first one. I'll use my highlighter. So 2 pi over 4, that was right here. If I want negative 2 pi over 4, I'm going to go this direction too. So now your point is right here. You go back. So this is your new point right here. That's where A prime would be. Next one, I'll highlight it for you. Negative 2 pi over 3. Well, 2 pi over 3 is right here, but we're going to go back negative 3. So instead of being here, I will be right here. So this is where the prime is. Negative pi over 2, that's this angle, but I'm going to go back negative 1, so I will be right here. That is where C prime is. Okay, here's the next example, 7 pi over 6. Guys, notice this is 1, 2, 3, 4, 5, 6 equal sections of 30 degrees. 30, 30, 30. This is 90 right here, okay? So this is 7. This is 7 pi over 6, okay? So if I want to do negative, if I want to go negative 7 pi over 6, I have to go clockwise. I'm going to go this direction, and I'll be right here. So this is the angle negative 7 pi over 6. From there, I'm going to go back 2. So I'll be right here. So this is your point. Next, we're going to now go from polar coordinates to rectangular coordinates. Oh, wait, before we do that, let's talk about different variations. So I'm going to go back to the first example. I think it was 2 and then 2 pi over 3. That is right here, because this is the angle 2 pi over 3. Okay, so I want to get more variations of that. I want to get more of the exact points. How do I write another point which will be at the same location? You can do that. What's the quickest way to find another point? Yep, add 360, add a circle. So 2 pi over 3, if I add another circle, if I add 2 pi, make sure you get the same denominator. So this will be 6 pi over 3. You get 8 pi over 3. So this is another point that's in the exact same location. I just made a loop. Does that make sense? Okay, so the formula for that was I have my radius, and with my angle, I just added 2 pi. And I can do that many times. I can do it once, twice, so I'm going to put in there. So that's the formula to find another variation, or another point that's in the exact same spot. Now, another way is I can go, let's look. I can go this way right here and then do a negative radius, correct? Okay, so I know this is 2 pi over 3. What is this angle? What do I do? How do I go from here to here? I add pi. Okay, so this is a straight line. I'm going to add pi. So basically, all I need to do is add pi, and let's see what I get. So I have 2 pi over 3. I'm going to add pi, so that's 3 pi over 3. I get 5 pi over 3. So this angle right here is 5 pi over 3, but I'm not in the same spot. What do I do? Yep, I'm going to go -2. So that will give me right here. Yes, I see what you're saying. The radius needs to be -2, but I still need this angle. So guys, looks like my formula is another variation is to make this negative and add pi to it. Okay? And if I want to keep going, what I did was I did -r theta plus pi, correct? If I want to keep going, just make another loop. Make another loop. So just add 2 pi however many times you want. Does that make sense, guys? Those are the two ways to find your different types of points. You could just keep your radius the same and add 2 pi to it, or you can give your radius negative and add pi and 2 pi to it. Okay, so I'm going to give you guys a few moments to find more points using those two formulas. Now we're going to go from polar to rectangular. Remember, polar is radius with an angle, and rectangular is what you've always done, x and y. So for example, let's say I have the radius is 3, and that is your angle that I'm giving you. Actually, let's do this. Let's do that. Okay, so I'm going to say to find x, I'm going to put my radius, which is 3, cosine of theta, which is pi over 3. Well, cosine at pi over 3, if you need a picture, it's right here. So I know that that x value is at 1/2, and the y value is at square root of 3 over 2. So this is 3 times 1/2, which is just 3/2. That's my x value. Now let's find my y value. radius is 3, and I'm going to do sine at this angle, pi over 3. So sine at pi over 3 is square root of 3 over 2. So y is just 3 square root of 3 over 2. So those are my coordinates. You try. Okay, so now we're going to go from rectangular, which is with xy, to polar, radius and an angle. So I'll give you an example. Let's say I have 3 and square root of 3. This is my x value and my y value. So looking at this formula, if I want to find r, I'm going to square root both sides. So square root, yeah, I know I said it weird. X squared plus y squared equals r. Okay, so guys, this is your other way you can write the formula. There's 2 ways. All right, so I'm going to use this bottom one to find r. So the x value will go here, and the y value goes right here. The square root cancels out with this squared. 3 squared is 9 plus 3. We get square root of 12 as my radius. And I can split this up. This can be written as 2 square roots of 3. So that's my radius. Okay, so I found my radius. So for r, I found that it was 2 square roots of 3. Now let's find my angle. This is the formula I use to find the angle. So tangent theta equals my y value is square root of 3. My x value is 3. Do you guys remember where tangent is square root of 3 over 3? So here is pi over 3, and this one is pi over 6. And the coordinate at pi over 6 is square root of 3 over 2 and 1/2. So that means, let's see. This will be square root of 3 over 3. So it's this one, pi over 6. So that means theta is pi over 6. Another way you can do it is you can just take the inverse of both sides, cancel, cancel, take the inverse of this side, type this into your calculator. Type tangent inverse of square root of 3 over 3, and that will give you theta. So I know that theta is pi over 6. So my answer will be 2 square root of 3 is my radius, and theta is pi over 6. And that is my answer in polar coordinates. You guys try. Also, guys, just one more comment. This coordinate right here is 7 pi over 6. This also would give you square root of 3 over 3 for tangent. Do you guys know why I chose pi over 6 instead of 7 pi over 6? Huh? Right, it can't be in the third quadrant because look at the original x and y. X and y are both positive. That means it has to be in quadrant 1. That's why I didn't choose this one. Okay? Even though both of them will give me square root of 3 over 3 for tangent. I picked the one in quadrant 1 based off of this coordinate. Now, guys, what if it was like this? Then I would choose this one, 7 pi over 6.